Grade 10 Mathematics. Linear functions. Oh, linear systems. Okay, linear systems. Part 2. Last time, we talked about linear systems, part 1, and we introduced the method of comparison. Today, in part 2, we will introduce another method, which is called substitution. Let's do an example. I have y equals 3x minus 8, and also 5x plus y equals 6. I will call this equation 1, and this is equation 2. I want to find the value of x and the value of y such that when I put the values of x and y into this, it's satisfied. This equation is satisfied. And also when I put x value and y value into the second equation is also satisfied. So this is called the linear system because I want to satisfy both equations. To find the x, y, satisfy both equations. How do I do it? Method of substitution. Look, this is y. Y is 3x minus 8. And this y, of course, the same y because they are one system. All right. So what I do is replace this y by 3x minus 8. And this procedure is called substitution. So I go ahead and do the substitution. 5x plus y. I replace the y by 3x minus 8. And this is equal to 6. So this step is to put equation 1 into here, into equation 2. So I substitute 1 into equation 2. And when I do that, I get this. I call this 3, equation 3. So I add 5x and 3x. I got 8x. I move the negative 8 to the right-hand side. Then I have 6 plus 8. 6 plus 8 is 14. And I divide this equation by 8, so I can get x. So what is x? X is 14 divided by 8. And this, if I simplify this, I get 7 over 4. So 7 over 4 is my x value. So the next step is to find the y value. I can put 7 over 4 into here. Or I can put 7 over 4 into here. So let me put this into the first equation. If I call this number 4, I put 4, substitute 4 into 1. Put 4 into 1. Then my y is equal to 3 times x. X is 7 over 4 minus 8. Let's do this. That's 21 over 4 minus 8. Do common denominator. Common denominator is 4. And the numerator should be 32. And I do that, I get negative 11 over 4. So my answer is x is 7 over 4, and y is negative 11 over 4, or I can write this way, 7 over 4, comma, negative 11 over 4. And that is my answer. And that answer is using the method of substitution. It's quite straightforward, right? Good. Let's do another example. I have 5x plus 2y equals 18. That's the first equation. And the second equation is 2x plus 3y equals 16. I call this number 1, and I call this number 2. Okay. Remember, we are doing substitution. In this system, I have the choice of finding the y here, and then I substitute the y into this one. Or I can find the x from the first equation, and then substitute x into this x. So it's entirely up to you. Let's, for example, if I want to find y. So the first is from 1. I write 2y is 18 minus 5x. I just move the 5x from the left side to the right-hand side. So this. And I want y only. I don't want 2y, so I divide this equation by 2. So 18 divided by 2 minus 5x divided by 2. So I call this number 3. So how do I get this? I divide equation 3 by 2. That's how I get this. And then I substitute this y into the second equation. So substitute 4, equation 4 into equation 2. One thing you should remember this. We get this y from the first equation. So when you get y and you want to do the substitution, you cannot substitute y into first equation. This way you get nothing. So find y from the first equation and substitute your y into the second equation. That's how you do it. Okay, so let's put the y, substitute y into equation 2. So I have 2x plus 3. Now this y is replaced by this. Look, 18 over 2 is just 9. 9 minus 5x over 2, bracket, okay, so e equals 16. Expand this part. (27) 15 x over 2 equals 16. Now, you will think combine 2x and 15x over 2, but don't do that. I recommend get rid of the denominator first. So multiply this by 2. So let's say this is 5. I multiply 5 by 2. The reason I do that is to get rid of the denominator too. So I get 4x. Oh, this is not here. This should be here, okay? This should be this line. So 2 times number 5, so I get 4x plus 54 minus this. You multiply this by 2, you get 15x. And don't forget, you have to multiply the right-hand side by 2. And then you simplify this. 4x minus 15x. You get minus 11x equals 32 minus 54. What is this? It's negative, 54. 54, okay? 54. So it's negative 22. Now you divide this by negative 11, right? So let's call this 6. Now I divide equation 6 by negative 11. So I get x here. And then, see this negative? Negative divided by negative is positive. 22 divided by 11 is 2. So I have x equals 2. And then you can substitute x into either equation 1 or equation 2, or even this one. You put this 2 into x and you get y. So let me do that. Call this 7. And I have substitute 7 into, substitute 7 into number 4. Oh, it's very annoying. I have an insect flying around. Okay, so it's annoying. All right, so I have y equals 18 over 2 is 9 minus x is 2. Look, 2 times 5 is 10. 10 divided by 2 is 5. Or you can see that x is 2, 2 and 2 cancel, so it's minus 5. And 9 minus 5 is 4. So I have x equals 2, y equals 4. This is a pair of my answers. Or you can write 2, 4 is my answer. This is my answer. Okay, this is the second example. I want to say something from the last part 1 lecture. In part 1 lecture, I gave an example, which is this. Let me write this. 2 over x minus 2 over y equals 1 over 2. And another equation is 1 over x plus 5 over y and equals 3 over x, 3 over 4. We did this in part 1 using comparison method. Let's do this same set of equations using substitution. Okay, how do we do substitution? Let's do this. Let's move this fraction to the right-hand side. So I have 1 over x equals 3 over 4 minus 5 over y. So let's label this equation 1, equation 2. This from equation 2, I just move this term to the right-hand side, I get this. I call this 3. Now, in equation 1, I can rewrite equation 1 so that you can see it, rewrite equation 1. So how do I rewrite? Instead of 2 over x, I can write 2 multiply 1 over x. It's the same thing, is it? 2 over x is 2 times 1 over x. And I keep the next term, 2 over y is equal to 1 over 2. I call this number 4. Now you see, 1 over x is this. Here, I have 1 over x. Now I can do substitution. I replace this 1 over x by this whole thing. Okay, so substitute 3 into 4. So this is what I have now. Substitute 2 times 1 over x. 1 over x is 3 over 4 minus 5 over y, close the bracket, and minus 2 over y. So this bracket is equivalent to 1 over x. And I still have 2 over y here, and the right-hand side is 1 over 2. Let's expand this. Look, 2 times 3 over 4. Don't multiply 2 and 3, you got 6, because 2 and 4 can be simplified. So it becomes 3 over 2. Minus. This time that cannot be simplified, so it's 10 over y. Minus 2 over y equals 1 over 2. Y here, these two terms can be combined. And I also can move this 3 over 2 to the right-hand side. So I combine these and move 3 over 2 to the right-hand side. So this is negative 10, negative 10, negative 2 is negative 12. 1 over 2 minus 3 over 2. What is 1 over 2 minus 3 over 2? It's 1, is it? It's negative 1. Do you see that? So negative 12 over y is equal to negative 1. What is y? Y is 12. Because it's very simple. If y is 12, then 12 over 12 is 1. So this is negative 1. And the right-hand side is negative 1. So y is 12. So now once you have the y equals 12, you can put y into either number 1 equation or number 2 equation, you get x. I'm not going to find x because this is quite routine. The reason I repeat part 1 example here is to show you that this was solved by comparison. And this same set of equations can be solved by substitution. That's my purpose. I can do this by substitution. I'd like to make one remark. The topic of the lecture is entitled Linear Systems. Now, I must tell you that this is not a linear system. Linear system is for so the first example, here is my first example today. Linear system means y has a power 1, or you can say exponent. The exponent of y is 1, the exponent of x is 1. So here, the exponent is 1, y is 1. When all the exponents are 1, then this system is called the linear system. Let's look at today's second example. Today's second example here, exponent is 1, exponent is 1, exponent is 1, exponent is 1. So this is a linear system. But here is the exponent 1. You may say that this is 1, but that is not right, because this is 2 times x to the negative 1. This is 2 minus 2 times y to the exponent negative 1, and equals to 1 over 2. So negative 1 here, negative 1 here. It's not a linear system. However, it can be solved by using the idea of linear system. Okay, it can be solved. Now here, you solve this system by substitution. Okay, so that is today's lecture, linear system, part 2, substitution. I want to tell you that this is the telephone number. Now, if you want exercise, homework, then you need to join the class. After you join the class, you will get notes, you will get exercises, and you send exercises back to me. I will correct it, and we will make comments on your work. And if you have any questions, I can answer this using real-time, say maybe FaceTime or something like that. So this is using FaceTime or using email or using messages. It's just a distance teaching. When the COVID-19 is over, so when students can come to my class, then we can also have face-to-face in-class lesson. All right? So if you have any questions, call this number, please. Thank you for watching. See you next time for part 3.